Welcome everyone to our latest webinar, Site Survey Simplified, How to Collect, Organize, and Share Data Like a Pro, featuring a Tier 1 career case study. My name is Amna, and I will be introducing our presenters today. So first off, we have Guillaume Poucarou. He is the product manager for iBwave Mobile. Guillaume has more than 5 years of experience at iBwave, overseeing major deployments around the globe. He manages iBwave's Android apps that streamline wireless network deployments by empowering field teams. Guillaume holds a Bachelor of Information Technology Engineering from Montreal. And our special guest speaker today is Nikhil Gogate from Solutalia. Nikhil is the Senior Director of Global Business Strategy. He is responsible for driving business development and marketing strategies for Solutalia. In his almost 9 years with Solutalia, Nikhil has played various roles including RF engineering, DAS field operations, business development, and marketing. Nikhil designed AT&T's first 4G LTE network in the Virginias and subsequently provided technical oversight for the design's extension and densification in the market. Nikhil has a master's in electrical and telecommunications engineering from Drexel University in Philadelphia. Before we start the presentation, just a few housekeeping items to mention. You will receive today's slides and the recording of this webinar by email within the next few days, so keep an eye out for that. And thank you for all submitting all the registration questions. But during the webinar, if you have any questions, please feel free to type them in the questions box, and we will get to them towards the end of the webinar. And now, without further ado, I will hand it over to Guillaume, who will get us started. Thank you.
Thank you, Amna, and thank you very much to everyone attending the presentation of our case study today. Let's now start this webinar. First of all, just a few words on iBwave for those of you who are new to the industry. We are a software company. Our software solutions are the global industry reference, allowing smarter planning, design, and deployment of indoor wireless projects, regardless of their size, complexity, or technology. Along with innovative software, we are also recognized for world-class support in over 90 countries, the industry's most comprehensive component database, and last time I checked, we were at nearly 300 different manufacturers from around the world. This is amazing. And finally, a well-established certification program. So the agenda for today. A lot of things to talk about, but we'll be efficient, I promise. First of all, a quick introduction to explain our motivation to organize this webinar. We will then jump into a comparison between the traditional survey process and the modified process that was used in this project by a Tier 1 carrier, which unfortunately we cannot name. I will then hand off the presentation to Nikhil, who will explain the Solutalia solutions used in this project, the UE versus scanner pros and cons, as well as the results of the case study. So he will have the best part in this. Finally, both of us will conclude with what's next in terms of improvements for our solutions, and we will then have a good 10 minutes left to answer your questions. So please write them down at any time during the webinar using the box Amna just showed, and we want to hear your thoughts on this. Introduction. Why this webinar? Well, if there is one consensus this year amongst the network operators we visit around the world, it is status quo is not possible. And we keep hearing this. Everyone in the industry needs to do their part to bring down the cost of deploying networks and also not be afraid to integrate closer together to form a more efficient ecosystem. The integrators are also regularly on the lookout to optimize their costs, especially those working on bids where they may not win. And finally, in general, everybody just hates losing time with inefficient processes, myself included. I think technology is there to help when it's done properly, of course. So the following content is really aimed at everyone who's joining us today. Site survey. This can be a broad term. What do we mean exactly by this? Well, today's case study will focus on a small part of it, the floor plans and pre-install measurements, but it can also involve a lot more data. For example, your customer requirements, which might be an Excel spreadsheet, floor plans annotated with a lot of construction notes or markups, as they are sometimes called, dozens, hundreds, or even thousands of photos, depending on the scale of your project, which may be contained inside a zip file, and measurement log files, which could be received as a PDF report or the CSV files. So those should be familiar to most of you working on site surveys. And what happens to all this data after it is gathered? Well, it is sent across, usually across various channels, because most of the time they are not captured by the same person. You will find them in emails, corporate network drive, cloud storage, and also paper plans. We can then spend a lot of time organizing all this data. For example, by manually creating a photo report that will mark the location of each picture on a floor plan. I see this regularly. And post-processing all the RF measurements to generate the multiple plots and PDF reports that are required. But in the end, what really motivates us is how do we help the RF engineer have a clear view on all this data? Yes, site surveys are expensive, but our users tell us the most costly design errors are actually discovered far later at the network installation phase. So we need to make sure the RF engineers see those pictures and have those measurements ready in iBwave design so they don't end up placing antennas in a skylight or not having the required data to properly calculate the dominance over the macro, especially close to the windows on the edges of the building. And this is the challenge that leads us to iBwave Mobile Note, which was used in this case study. Speaking of the case study, this is my last slide before we jump right into it. iBwave Mobile, some of you might hear about it for the first time. Some might be familiar with an older version of the app. It's evolved quite a lot in the past 4 years. And some of you are already users. But what it is exactly? In short, it is an Android app that basically helps capture and, most importantly, centralize all the survey data inside a single file, which we call iBwm. This file can then be imported inside iBwave Design or even the free iBwave viewer, allowing you to see all your photos, notes, and RF measurements directly on your iBwave plans. If requested by the carrier, from there you can also generate some site survey reports that are available, such as the photo location or measurement plots for the KPIs, and even export all your pictures if you'd like to. So finally, our Tier 1 carrier project. What was it? Well, here is the venue. It is a 6 floors office building of roughly 215,000 square feet. That makes 20,000 square meters. It has an existing on-air DAS running over 850 megahertz for UMTS. And where it got complicated was on the logistic front, mostly because of the security at the site. So one of the main requirements was to avoid any subsequent site visit. And even more complicated, we only had 1 hour to collect all the data and get out of the building. This basically meant, well, we cannot do 2, 3, or 4 walks of each floor. We only have time for a single walk to collect all the bands. And, well, there is no room for mistakes. We have to do it right the first time. The goal of this project was to upgrade the existing DAS to 1900 LTE. On a side note here, we also received some questions about Wi-Fi during the webinar registration, but unfortunately it was outside of the project scope here with the carrier, but we do have another webinar on Wi-Fi coming soon. Some of you might ask why the 1900 band was chosen. Well, it happened the existing DAS infrastructure in this building already had 850 and 1900 band amplifiers, and the 1900 was unused. So from a budget standpoint, it was cheaper to deploy this band as opposed to adding amplifiers and or antennas to support the other bands of the carrier. Another advantage of using a mid to high frequency band like 1900, where the attenuation is higher, is to better contain the signal inside the building to avoid interfering with the macro outdoor sites. So along with the 850 and 1900 bands, the 700 and 2100 also needed to be collected to perform some extra analysis later. Another interesting thing we did is to collect data every other floor, highlighted here in red on the picture, for a total of 3 floors. It is a best practice to collect every other floors and even every third floor in a high-rise building, as there is no real value added to collect data on all floors unless the building is very close to a macro coverage boundary edge. Finally, related to the fact we had to absolutely avoid a second site visit, which I just discussed, we also had to validate the integrity of the survey data on site, and I will explain how a bit later. So all of this needed to be done in an hour. How did we do the survey? At the center of the solution was an LG G4 phone from Solutelia, and it was loaded with many apps. First, the Solutelia Wind Benchmark app, their Wind IBflex module, as well as the iBwave mobile note application, represented here by the letter M inside our red logo. The phone was connected via Bluetooth to a PCTEL iBflex scanner, and Nikhil will actually explain a bit later the choice of the scanner versus having multiple UEs to collect on all bands, but it was chosen here mostly because the customer already had one available. Finally, the iBwave cloud was also used to exchange the project and survey files between the carrier and the vendor. And this last point actually brings us to the next slide about this process with the vendor. First, on the left, we have the traditional approach, which the carrier was using prior to this. So first, he would send the floor plans or an IBWC file to the vendor for him to perform the walk test. He would then have to wait an unpredictable amount of time, depending on the vendor, for him to generate and deliver the CSV files, since it might not be on the vendor top priority list for the day. And we heard this even takes up to 2 days in many cases, which is a big delay in some important projects. Once received, the designer then has to import all the CSV and tab files inside iBwave Design. And to give an example, here we tested 3 floors and collected 4 bands per floor. Since we can only import 1 band at once per floor, this would have meant a total of 12 manual imports to perform. And for each of them, the designer has to map the columns of the CSV file and adjust the imported survey traces on the floor plans if needed. Fortunately for him, he didn't have to do any of this since they modified the approach this time around. The first step is very similar, the only change being an iBwave mobile file, the IBWM, is shared with the vendor instead of the old IBWC file. Second, the vendor was using the iBwave cloud. So the carrier received the link to download the new IBWM file, this time filled with all the survey data. As soon as the walk was completed, the carrier then imported this new IBWM inside iBwave Design, and all the data was automatically available on the floor plans for his analysis. My last slide before handing over to Nikhil is a quick overview of the phone that was used for this case study. Nikhil will even show it in action in a few slides, and you see here the main steps of the process. First, the IBWM file was opened inside iBwave mobile note, which you see on the left here, and it was shared to the Wind app that was installed on the same phone. Inside the Wind app, then the PCTEL scanner was configured, and the data was collected for all bands with the phone connected to the scanner. As soon as the survey was stopped, the scanner data was automatically exported back to the iBwave app. And finally, we validated the integrity of the data inside the iBwave mobile application, where we can switch between bands and technologies to see all the KPIs collected in each data point. So I will now hand over the presentation to Nikhil, who will present the rest of the case study.
Thank you, Gil. Hello, bonjour, salam alaikum, namaskar and ni hao to all our friends who are joining from around the world. Greetings from Solutalia. Thank you so much for joining us for this webinar today. I would like to start off with a brief introduction to our company. Over the past 13 years, Solutalia has emerged as a leader in RF engineering services, and it is this very experience that now benefits our software division. With its award-winning WIN solution and features such as live plots and live processing, Solutalia offers a cost-effective and efficient way to monitor, test, and optimize the rapidly growing networks of today, which is in line with what the carriers are asking for. The focus of this webinar is a case study that we worked on with a Tier 1 carrier in the United States. Guillaume has already discussed the specifics about the venue, the scope, and the tools that have been used. And in my portion of this presentation, we will focus on understanding the tools in some more detail, as well as the key differences between collecting the data using scanner and UE, and finally we'll review some of the results of the study and also see a brief demonstration. So to collect the data for the case study, a WIND BM or benchmark UE was used, which is one of the 3 tiers of Solutalia UE test devices that allow customers the optimal choice of functionality and pricing in all situations. All these 3 versions are integrated with the iBwave mobile platform and the iBflex scanner. But the carrier chose the WIN BM of the 3, and it was available for testing at that moment. There are 2 solutions that are available to collect indoor neutral host data with WIND, UE-based and scanner-based. So let's take a look at what these both solutions look like. When you're collecting indoor benchmarking data in a synchronized manner with multiple devices or UEs, a tethered master-slave configuration as shown here allows the user to collect the data quickly and efficiently. The master device or the WIND console in this case controls multiple devices connected via Bluetooth and can be used to push the floor plans and test scripts to the connected UEs. The image here shows a neutral host setup with each UE representing a different carrier, but let's say you're talking about a single carrier, then this configuration can also mean different UEs that are locked to various bands and technologies that the carrier is interested in testing using the in-app network forcing functions. Now the second option is to use the Siegel iBflex scanner. The first-tier carrier in our case chose to use this configuration to collect the data at the venue, not only because the scanner was readily available, but also because the carrier was keen to understand and see the automated scanner data integration into the iBwave mobile platform. The WIN UE was connected to the scanner via Bluetooth, and then using the in-app screens in the WIN, the scanner was configured to perform top-end scans for LTE 700, LTE 1900, 2100, as well as UMTS 850. Okay, at this point, we are going to take a quick look into a demonstration of how this was done. All right, so you start with the iBwave mobile planner or note. You have, once you open that up, you can go ahead and select your project, select the floor plan that is available to you. This is all within, again, this is either mobile planner or mobile note. Once you share the button, it will bring you straight into WIND. Once you're inside WIND, the floor plan is already loaded. You then have to go ahead and start setting up and configuring your scanner. It is very easy to pan around the entire screen over here and look at different things. Once you are in the scanner, you can use a pre-configured text file to set up the scanner scenarios. You can set up the different technologies and frequencies. You will have the ability to manually adjust these bands as well as the various bandwidths, and you can either put the channel number or the frequency itself. And once you've set the configuration, you would then be able to go back into the the map screen and be able to click on the floor plans to collect the data points. Now, we have to make sure that you're looking at the correct scanner KPI for the visual representation on the map. And again, the map itself is very fluid on the screen. You can easily zoom in, zoom out. You're able to look at the UE-based KPIs on the device itself, and you can go to the top-end screen on that device to take a look at what the scanner is collecting. Again, as you click around and as you walk and click on the map, you will continue to collect your data, and all of this data is getting stored on the log file. As I said, you still have the option of looking at various other screens that are available. Once the testing is completed, you would then be able to stop the test from here, and that information will get straight transferred into the iBwave mobile node or the mobile planner, whichever platform you have loaded on that device. So once the data is back, you can import it into iBwave, and there you have it. You will be able to see all of that information in your iBwave mobile platform. As Guillaume mentioned, you will be able to click on individual points and see more detailed information. You can you have the options of looking at different bands as well as different bands and different technologies all within to verify that the data has been imported. Let us now take our discussion in a slightly different direction. One of the most commonly asked questions is, when should I use a scanner to collect the data? When should I use a UE? Which one is better? But before we answer these very important questions, let's take a quick peek into some of the broad differences between a UE and a scanner. Now, fundamentally, scanners and UEs are two different animals, but to a large extent, they can accomplish similar tasks. I mean, UEs, as the name suggests, are user devices meant for communication, but they give us really cool network KPIs from an end subscriber's perspective. Since the UEs are consumer products, they have more stringent requirements on size, processing power, and precision. Scanners, on the other hand, are specifically designed and calibrated to collect RF information, albeit they don't provide you information about user experience, but they're pretty accurate. Let us look at some of the obvious differences, such as weight and form factor. UEs are obviously lighter and easier to carry around during testing compared to scanners that tend to be a little bit bulkier. Although I have to admit that some of the newer scanners have a much smaller form factor and are much lighter than their predecessors. Another obvious difference is user experience. When you collect data with a UE, you are in a sense simulating an end subscriber using a voice or data service, and you have access to UE-specific KPIs such as the mobile's transmit power, the uplink and downlink throughput speeds, dropped calls, and things like that. A scanner, on the other hand, can provide really accurate readings of the signal, but it cannot simulate the user on the network. Cost, again, is an important factor. UEs certainly offer a cheaper alternative to scanners, which tend to have a hefty price tag. In terms of network interaction, UEs register themselves on the network. They interact with it, which is great because it gives you the true user experience. On the other hand, scanners just passively read the network. They don't interact with it in any way. And this is great as well because it gives you the opportunity to test the network without having to, worry for things like SIM cards, and especially in cases where you're trying to investigate missing neighbors in your networks. Scanners work great there. Since UEs have a limited processing power and battery life, the rate at which they collect data, in a sense, the number of data points it collects per second is low in comparison to scanners. Scanners, on the other hand, are calibrated to collect data at a much higher resolution than UEs can. What band an UE can support can vary from carrier to carrier, from region to region. For example, a Samsung device made for the US markets versus the one made for the EMEA markets will support different bands. Similarly, same device for two different carriers such as AT&T and Verizon could have very different bands. Therefore, while testing with UEs, one needs to make sure that it supports the bands that you need to be tested, and scanners, on the other hand, inherently support a wide range of bands. Scanners also tend to have a higher dynamic range compared to UEs, which means they are more sensitive and are able to detect very low-powered signals in the presence of high-powered signals. So if the dynamic range is small, the strong signal will block out the weaker signal. If the dynamic range of the scanner is high, weaker signals can be seen even if the strong signal is present. So let's say, for example, let's say that the dynamic range of a scanner is about 20 dB. What that really means is it allows us to detect signals that are 20 dBs weaker than the total power for that channel. So now that we've seen the broad differences between the scanner and UEs, let's try to answer that question that everyone has. Which one is better? Which one should you use? And to be honest, the answer, it really depends on what you want to achieve with your data collection. And for some people, that might also mean what budgets they have. That does play an important role. But in reality, there's no set rule on whether to use a scanner or UE to collect your benchmarking data. Both will provide you with that information. Now, as I've mentioned before, if you're looking to simulate user experience and want to collect data such as uplink and downlink throughputs and UETX power, accessibility, retainability, then UEs become your obvious choice. But if you want to only passively scan the network and do not necessarily care for the user experience, then the scanners will be just fine. On the other hand, if you are wanting to scan an area, let's say with extremely poor coverage where your UEs won't even register on the network, or if you're interested in troubleshooting missing neighbors, then scanners become your obvious choice. UEs will only measure signals from channels that the network instructs it to measure based on an existing neighbor list. But the scanner is able to see beyond that. Those who have access to both a scanner and UE have often resorted to collecting both kind of data. I mean, they're both similar, but they provide very different perspectives about your network. Now let us step back into one more time and review what the carrier did in order to be more efficient with the data collection and the subsequent transfer of that data into the indoor design. So let's take a look once again into our case study and try and answer these questions. How was the carrier more efficient in doing this, and what were the results of this case study? So based on the case study, it was concluded that the carrier saved about 80% time by using the automated Wind iBwave mobile note approach compared to the traditional manual process of importing the data into iBwave. Now this saving represents the time taken for the collected data to go from the data collection ecosystem, which is Wind in this case, to the indoor design ecosystem, which is iBwave. As you can see, it took us 47 minutes to walk 3 floors where the data had to be collected. We had to respect that 1-hour time frame that was given to us to complete this data collection. The scanner was collecting, as I mentioned earlier, LP 700, 1900, 2100, and UMTS 850 bands. In the traditional approach, the data collection CSV raw data files that we received from the walk test were separated by band and floors, and they all have to be imported separately into iBwave, as Guillaume mentioned. This process is very time consuming, and it can take up to about 30 minutes or so for a venue of this size. So if you're talking about a larger venue, such as a high-rise building with multiple floors, you are talking about a lot of man hours right there. So in the modified approach, the data import from Wind to iBwave took only about 2 minutes per floor on an average. That really represents a massive saving in time. Now, Guillaume has previously compared the various steps in the carrier's traditional approach versus the modified approach from iBwave's file format perspective. Let's take a look at that same comparison one more time from an end-to-end process view. So in the traditional approach, the vendor completes the walk test for the carrier, and then using traditional post-processing tools, exports this data into CSV files. When the carrier requests for this data, more often than not, there is a delay that is involved in receiving this information from the vendor. Once the relevant CSV files for the data and the geocoded floor plans with the tab files are received, the carrier engineer has to manually import these CSVs into iBwave and then run the propagation predictions. For a venue of the size comparable to the one in this case study, this can take 2 or more days if you're lucky. In contrast, in the modified approach, the data collection is accomplished with the iBflex scanner connected to the Wind BM UE. that also has iBwave note on it. Once the walk test was completed, the data was automatically imported into iBwave mobile note in just a matter of minutes. The data was instantly uploaded to the iBwave cloud and was available within iBwave design, and the engineer could run his predictions right away. This entire process took about half a day, and essentially the total amount of time it took for us to see the data in iBwave was about the time it took us to collect the data, plus maybe a few more minutes to import that data into iBwave mobile node. So this really sums up the result of the case study. As you all can see, the modified approach tremendously saves time and energy and effort for everyone that is involved. And most importantly, it helps provide a path towards integrated and cost-effective processes that the carriers are asking, not just for themselves, but for all the vendors as well. Before I hand it back over to Guillaume, I want to take a brief moment to introduce this new unique bundle that Solutelia is now offering, where we are bundling the Win products along with iBwave mobile products ready to use on a tablet. Through this bundle, Solutelia offers significant cost savings as well as a single point of contact for all your support. Back to you, Guillaume.
Thank you very much, Nikhil. So to summarize our presentation, I'd like to highlight the main takeaway of the case study here with the feedback received from the carrier. So as you just mentioned, the complete survey data was available in iBwave design 2 days faster than with the traditional method, which in the end allowed him to deliver his project faster. Finally, as promised at the beginning of the webinar, we would like to finish by giving you a sneak peek into what's coming soon. On the iBwave front, we will have an improved user interface for phones, as you can see on the right here. One last small thing that is missing is we will now send all the transmitters and zone information from iBwave design to our partner mobile tools. And in addition to the iBwave cloud, you will now also have the option to exchange the mobile file, the IBWM, directly through USB for those very, very large survey files where, like I mentioned, we've seen those before. Thousands of pictures are taken or high-resolution videos are recorded. Nikhil, will you please share what Solutelia is preparing?
Certainly, Guillaume. So some of the things that we are focusing on this year, we are always looking to expand our capabilities and portfolio, and we are certainly looking to supporting more scanners in the future. So that's certainly on the cards. And Win currently supports collection of CW data, but we want to work with iBwave to be able to integrate that information into the iBwave mobile products as well.
Thank you, guys. Now we have some time for questions. So we had quite a few questions. Let's see. The first one we have is, how are the in-building coverage traces geocoded?
Okay, I can answer this one. So since both applications are installed on the same phone, we exchange the iBwave plan directly, and we exchange a picture of the, an image of the floor plan. So the coordinates are referenced exactly on the picture as the XY coordinates, and this is how we make sure that the points are exactly located either on the Solutelia or the iBwave side, and there can be no mistake between the location of the survey points.
Thank you, Guillaume. So another question, just a reminder to the listeners, if you still have questions, please feel free to type them in the GoToWebinar chat box, and we'll try to get to them. So the second question I have here is, what collection data do the carriers like to have submitted to them?
Amna, I can take that question. So from a pre-designed benchmarking perspective, usually signal strength, signal quality, and cell ID is sufficient. If we consider LTE, then we're talking about RSRP, RSRQ, PCI. I mean, occasionally carriers ask for SINR and RSSI information as well. If we so that was pre-designed. If we talk about post-build data collection, then in addition to the previous KPIs that I just mentioned, carriers also usually like to see the uplink and downlink throughputs, sometimes maybe the mobile transmit power as well.
Thank you, Nikhil. So another question is, while doing any survey, are we able to connect with our system at the same time in the office?
Yes. So a bit like we explained, we have a product that comes with iBwave Mobile, which we call the iBwave Cloud, and this allow you to upload your survey data from the field to the office, and also back and forth. The engineer at the office can upload it there and share the link with a surveyor. It doesn't need to be the same company or the same system. You can just send by email a download link to an external partner as well.
Thank you. Another question, what tablet platform can you use with Wind, and will iBwave work on the same?
I can answer that, Amna. So it needs to be an Android tablet. The one that we have specifically used recently is the LG device. It was an LG, I believe, a G-Pad X10 or something like that. But again, I mean, the basic requirement is that it needs to be an Android that will allow both Wind as well as iBwave mobile platforms to work on it.
Thank you. So another question is, after I finish the scanner collection procedure and export the information into iBwave, how do I create a report from the KPIs?
Sure. So from Solutelia's perspective, Wind has one other part of Wind is the Wind console, and Wind console is a product that not only allows you to see the information in real time, but it is also your processing tool. So if you have the scanner data or UV data, you'd be able to create instant on-site reports. So it's like post-processing, but it'll be done in a matter of seconds, and you can do it on-site. It'll give you a complete, for the UV, it'll give you a complete histogram. It'll give you the KPIs statistical summary, test-by-test summary, as well as all of your plots that you need in a matter of few minutes. And same thing for scanners as well. You'll be able to see all of the plots. You'll get the CSV raw data, everything in that report. I believe there is some sort of reporting capability on iBwave side as well, correct?
Yes, on the iBwave side, I would say it would be limited for the baseline measurements. So as you mentioned, the basic KPIs like PCI, RSSI, RSRP, we can run plots and reports on those ones because those are the ones that are used in iBwave design. But maybe for the more signal quality ones, we will not have those.
Thank you, Guillaume. So another question is, what is the benefit of importing the walk test with the mobiles in iBwave?
Well, here, like Nikhil mentioned in the case study, the carrier saved 80% of time by sending the site survey data in iBwave Mobile versus the traditional approach. So I would say time saving is the main benefit. And also, since in the traditional approach, we need to manually map each column, like this is RSSI, this is RSRQ, and also the last long coordinates. Sometimes they're not referenced using the same system, so it's also error prone. So I would say we also remove the human factor errors in the solution as well.
Thank you. So we do have some more questions, but I think we covered a lot of ground today. So I will just like to thank everyone, and we're giving you back some of your time so you can get back to your day. And I will just like to thank you for attending, and thank you to Guillaume and Nikhil for the webinar. Again, if you have any questions, feel free to send them our way and we can get back to them. And just one last reminder that we have recorded the webinar, and we do send out the slides and recordings of the webinar to everyone who has registered. So just look out for that in your inbox in the next few days. So thank you everyone, and I will now disconnect the call.